Hi there, welcome to Engineering with Mike. Today we're going to talk about composites. What is a composite? Well, it's a composite. It's made of multiple materials. And the idea is that by combining two different types of materials, you end up with properties that improve on both of them. So for example, carbon fiber epoxy, you see airplane parts, car parts made out of this material. It's a combination of a plastic and carbon fiber, and each alone would be inadequate for the task, but together they make a kind of super material. Another type of composite is fiberglass. That's again a plastic with glass fibers, and you end up with a very strong, durable material that neither glass alone nor plastic, epoxy, polyester, resin, whatever alone could not achieve. So what kind of freak show do we have here? Well, being a chemical engineer, I thought, what would happen if I combined some very different materials together, each with its own benefits, that I hope to sort of create a hybrid that has the benefits of both materials. But these are very unconventional mixtures that I made. So the plastic base, if you will, in these two experiments were epoxy. Okay, we got a quick set epoxy, JB Weld, very famous product. And the other plastic I used in the second experiment was this Loctite vinyl fabric plastic. It's kind of like goop. It reminds me of this goop product, which is it's a polymer, goopy, very smelly adhesive that where the solvent evaporates, and that allows the adhesive to cure. I would say it's a little weaker than the goop product. The goop product is available in Canada and the US. I'm not sure if it's available internationally, but it's very, very useful. High adhesion, high strength. This has great adhesion as well to things like vinyl, various types of plastic, wood, metal, everything. In the first experiment, I took good old-fashioned mortar powder, all right, and I combined that with this two-part epoxy. And you can see the remnants of what I did. I'll show you the actual patch that I made with it, but the material itself is right here, and after a couple of hours, it's still kind of tacky and soft. Now, what some people do is they combine the raw powder with the epoxy. I mean, that works, but basically you're using it then as just a solid filler. The way mortar, cement, concrete sets is it absorbs water. You hydrate the material and that causes it to cure and turn hard. If you don't add water, it just remains dirt. So I added water, stirred it up, and then I added the epoxy in approximately equal volumes to the mortar paste, and I stirred it up. It actually mixed very well. Now, why is this? What were some of the things going through my head as I did this? Well, a water-based material such as cement, Portland cement or whatever, mixed with a non-polar polymeric type material, are they going to be happy together? Is it going to cure even? Because you can create situations where nothing ends up curing. It just stays soft forever, which is useless. So I don't know what's going to happen. We're going to come back to it later, but right now it's supposed to set up pretty quickly, and it's been well over the 6-minute cure time for the epoxy, so something weird's happening. So we're going to find out. And likewise, I took the mortar, mixed it with water, and then I added this lovely vinyl, plastic, and fabric adhesive. And it looks like it's actually setting up quite a bit faster. So the volatile solvent in there was evaporating very quickly, it looked like. And, well, it's firmer. It's firmer, has some adhesion. Well, we'll see. It's not rock hard, that's for sure. It definitely moves. So we'll see. What I did was I patched the floor of this facility here. There's a crumbling floor that we roll industrial equipment over. And it was crumbling, so I had to repair it a little bit. So I used this as a patch. I used plain mortar in some cases, and that obviously that's set up fine and could take the weight of the equipment. But in parts I tried this weird epoxy hybrid. So we'll come to that in a little bit and see how they turned out. Just a quick interlude here. I wanted to talk a little bit about what the properties are of these different materials that I combined and what would be the theorized benefits of combining these two materials together. Well, cement, concrete, mortar, they're pretty good under compression. So that means loads that squish them. They can handle a lot of weight, but tension, they're not so great. Toughness, another mechanical characteristic, they're not so great either. You take a hammer to some cured concrete and, I mean, not a huge piece of it, but a small enough piece, and it will shatter. In contrast, you've got the epoxy. So epoxy is famously strong, pretty good compression strength, very good tensile strength. So when you try to pull it apart, it can handle those kind of loads. Toughness is good. You can whack it with a hammer, not too bad. And it's relatively lightweight. So in my particular situation here, I don't care about the weight or density of it. I'm more interested in its toughness. And it's waterproof as well, and it's easy to apply. You can spread it nicely, so it has a nice surface finish or a smooth finish. So the idea is that, well, if I mix these two together, maybe I can have a higher tensile strength concrete that is also pretty resistant to moisture, oil, that kind of thing. And it's also easy to apply. Like it goes on more like a caulk rather than a sort of a gritty, sandy mush. So that's what we wanted to find out. That's the hybridization. That's the taking of two different types of materials, and hopefully you get something in the end that can achieve the benefits of both of them. If it doesn't work, I'm going to achieve the benefits of neither and end up with a useless, mushy material that I can shape into things, but I can't make it adhere. I can't make it have any strength. I can't make it have any compressive strength or tensile strength. I mean, that's the worst case scenario. So, but we'll see. Maybe I'll get the benefits of both. Maybe I'll get the benefits of neither. We'll see. Before we go on, here's a table of common materials, some of which were used in this video, and it shows you the tensile strengths of these different materials. You can see that conventional concrete has a miserable tensile strength of 2 to 5 megapascals. So that's the reason why we want to combine it with epoxy or some other kind of polymer, so that it toughens it up, literally in the engineering sense, toughness, and also in the sense that you can exert different kinds of forces, tensile forces, on it without it snapping and breaking. So you can see epoxy is a very good choice. It's also a very expensive one. At the bottom of the list, you've got household adhesives, everything from cyanoacrylates like crazy glue to sort of PLA or other kind of more flexible adhesives that you use to glue things like paper together or cardboard or other home projects. Their tensile strength's not as good as epoxy, however, they're readily available and they still can contribute to an improved concrete polymer composite and improved tensile strength overall compared to bare, plain old concrete. All right, well, here's another aside. Apparently I'm a genius because I just reinvented the wheel. Epoxy and cement or concrete is called polymer modified cement or polymer modified concrete. So it's a thing, but I've done it a little differently. Apparently it's approximately normally 20%, 15 to 20% epoxy to cement or concrete. I had it about 50-50. So it looks like, mine's going to be a little bit tackier, better adhesion, but probably less compressive strength. So but I'm not doing construction. Well, I kind of am actually, but for my application, it's fine. I'll just have a little more bias towards the polymer properties and less, it'll be a little less cement-like. So it should work. Wait and see. All right, 36 hours later, let's see how our composites did. The one made out of epoxy, 50% epoxy and mortar, is fairly hard. It's not, it feels like very cured in terms of hardness, very cured epoxy. And the adhesion to this polypropylene tray is actually quite good. Oh, there we go. It will pop off. It's okay, nothing really sticks to polypropylene very well. The one that was made with this Loctite flexible adhesive, 50% mortar, 50% Loctite adhesive, the adhesion was pretty bad. And there's a lot of, it looks like it wasn't really mixed very well. There's still plasticky bits, and it feels noticeably softer. It's got a real mush to it. I can actually cut it if I wanted to. Looking at the floor repair I did, the epoxy mortar mix is pretty hard, but it's not as dense as, obviously, straight mortar. So we're looking at straight mortar, epoxy and mortar. Don't look at this. This is mostly epoxy with some metal fiber reinforcement. This is the sticky glue Loctite with mortar, and it's again soft. I'm not really sure the adhesion's very good. I'm pretty sure it'll just crush if I roll any heavy equipment over it. But this is going to do just fine. This is going to do just fine. It's got good adhesion. It's got good hardness. Kind of did the trick actually. And in the future, I'd probably use 75%, 80% mortar and 20% epoxy, just like they do with the polymeric enhanced cement they use today. So yeah, success overall. I'm pretty happy.